Hi folks, so the question we have in front of us today, guys, is from the World of Graphics textbook on page 270 under the chapter on developments. And what we're specifically moving on to in this developments chapter is the area of truncated cylinders. Okay, so what we've done previously is obviously normal developments, okay, with kind of a cube and box-like figures, and we progressed on to then truncated prisms and then eventually onto cylinders. Now we're moving on to truncated cylinders. So as we can see here, it says here, question 1, it says a compass lead is shown below, so we can see the kind of pictorial view of it here. Draw A, an elevation in the direction of arrow A, a plan projected from the elevation in the direction of arrow B, and then the surface development. Now in this case, in comparison to other questions we have done on cylinders, we can see that the top of the lead obviously would usually have an angle on it, and we can see the angle there is 60 degrees. Okay, so in this case, if we think of it as a cylinder, we can see the cylinder has been cut at an angle of 60 degrees, obviously to give this sharp point up here for obviously when you're putting into your compass to be able to draw. So starting off, we have to draw an elevation in the direction of arrow A and then a plan from above. Now when we look at the elevation, we're going to see essentially what usually you would have for a cylinder would be a rectangle, but obviously from the top of the rectangle we're going to have it obviously cut off at an angle of 60 degrees, and that's up 40 millimeters high to get that. And then from plan, we're still going to see a circle, even though we know it's cut at an angle, and the shape it's actually showing here is kind of like an ellipse, okay? But when we look down on top of it in plan, we would still see it as a circle, okay? So that's important to note. And what we're going to do then is we're going to split up our circle like we do with any time we're developing out a cylinder into our 30-60 degrees, get our series of generators, and we're going to develop out this surface. Only this time when we're developing it, we're going to have different heights, okay, going along the development, okay, for those generators. So we'll start in that there now. So as you can see, I've already drawn in my elevation and I've already drawn in my plan view. So it was a radius of 15, so overall the diameter was 30. I measured up 40 millimeters here, and then I projected up at an angle of 60 degrees to find the overall height of it. And then in my plan view I projected down and radius 15 drew my plan. Now as I said previously, what we have to do is from the plan view we are going to divide up our circle through the center, I should say cylinder, into 30-60 degrees. So 30 degrees both ways, then 60 degrees both ways. So there we have it. I've that divided up now. I'm just going to zoom in there a little bit better, a little bit more. Okay, now having divided it up, I'm going to use the clock numbers again. So 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. Okay, having done that, what I'm now going to do is send up my generators. So 12 and 6 are here up at the top, so I've got 12 and 6 there. Okay, just to note that I've obviously got 3 on the outside here, which will line up with that. That's fine. Now I've got 2 and 4 will line up together, 5 and 1, 7 and 11, and finally 8 and 10. So I'm going to number them now. I have 9 out here on its own, and I've got 3 on this side on its own, and then I've got, for this one I'm going to say 1 and 5. For the next one up I had 2, or next one down I should say is 2 and 4. Working backwards, so we have 7 and 11 here, and then finally 8 and 10. Okay, so obviously looking in at this side or this face here, I obviously know then that 8 is at the front, 7 is at the front, 6, 5 and 4. Okay, so what we're going to do, like we did anytime we develop a cylinder, okay, previously, what we do is we kind of have to roll it out, okay. And what you're going to do, if you think of rolling out a piece of toilet paper, the shape that you leave behind is a rectangle. We have to assume that this cylinder has not been cut just yet, okay. So I'm going to extend out this line, and I'm going to start off by also extending out the overall height of it, like that. And what I'm also going to do then is going to pick a start point. And as always, I'm going to start with 12. Okay, I'm going to start with 12 and we're going to finish at 12. So 12 is here. So what I need to do, like previous questions, I need to set up the lengths for my circumference. So I'm going to take the distance from 12 to 1, get that on my compass, which is the same as 1 to 2, 2 to 3 and so on, and I'm going to step it off a number of times until I get back to 12. So it'll be 12 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, 8 to 9, 9 to 10, 10 to 11, and 11 back to 12. So writing in those now, 12 went to 1, to 2, to 3, to 4, to 5, to 6, to 7, to 8, 9, 10, 11, back to 12, and we finish at 12. Okay, so we know the overall length of our development of this truncated cylinder, and it has to fit in within this section here. So what I need to do now is, all of those generators, okay, are at various different heights. We can see that 3, the generator that 3 is at this height. We can see that the 2 and the 4 are at this height, and then the 1 and the 5 are here, the 12 and 6 are here, the 7 and 11, the 8 and 10, and then the 9. So what I need to do now is I need to extend up my generators here and project across my various heights. So what I will do is project up my lines here. So for 1 and 5, and then I've also got 7 and 11, just so I know how high they need to go up. I'm looking over here to roughly get the height. Okay, you could do this all at once as well. 2 and 4 will be up here about somewhere, and then 3 up about 40 millimeters. 6 and 12 be up about here, so I know. 7 and 11 we've obviously got 8 and 10 be close to the top, and then 9 is at the very, very top. Okay, so you can kind of see how it's going to flow. Okay, but what we need to do now is we need to find those points. Now it was very easy, I could have just projected all of them up and projected them across, but I just kind of wanted to give you an idea of how this is going to flow. So for 12, I know it starts up here, 6 is the same, and it goes all the way to 12. So for that one I have to project the whole way across. So that's a point there on the 12, and also on the 12 here, and I then also on the 6. Okay, now what I'm going to do is I'm going to start with here, so number 3, which is in here. Okay, there. So there's my number 3 found, which is my lowest one. The next one is 2 and 4, so I know that's beside 3. So there we have it. There's 2, and there's 4. The next one is 1 and 5. There's 1 to 5. Okay, so you can see how this is going to flow in a second. We had 12 and 6 done. Now we're on to 7 and 11. 7 and 11. And then finally 8 and 9. Sorry, 8 and 10, I should say. And then 9 was already projected across, so there's my 9. Okay, so at this point now, I will, at this point, right here, I need to develop out this surface, so I'm going to heavy in this section here, because I know that's the overall length of it. Okay, as the circumference rolled out, heavy in this, and then I have to sketch in my curve. So I'll speed up the video while I do that. Right guys, now having done that, we can see the surface development of the object here, or of the cylinder, the truncated cylinder actually. So what we actually have, you can see obviously we've put in the curve here, okay, and that's where I've located on those generators all the various points. Now this curve could look a little bit different depending on how you started it. I started at number 12, okay, and I finished at 12, and we can see that 12 and 6 were kind of on the midway point up. So technically I had to go down to go up to go down again, okay. If I had started at the lowest point, which would have been say number 3, okay, if I had started at number 3, well then maybe my curve would have looked something like this, okay. It would have gone in like this, up to here in the middle and come down, but both answers would actually be fine, okay. Now just to finish off this question, we also have a surface on the bottom which is going to take the shape of a circle, so I'm going to put that, I'm actually going to put it on number 9, okay, and I'll explain why in a second, because we have a tricky part to the end of this question. So I've measured down there 15 millimeters because I know the radius of my base is 15 millimeters. So it's very simple here at this point now. Just draw in my base circle. Okay, now the final part of this question, guys, is a little bit tricky and it's something we haven't covered yet. We haven't done ellipses yet. And the shape you actually have up here, and it is in the book as well, which I'll just bring over to you again. That shape we have up there is actually an ellipse, okay? So what we're actually going to have to do is we're going to have to develop out that surface as well. Now this is something we haven't done, okay? But it'll be good practice for us regardless. So first of all, we're focusing on true lengths and kind of true distances. So I'm just going to pull this down here because I'm going to need a little bit further room, okay? Now that ellipse is going to be kind of like an egg shape, okay? And it's going to attach on. I'm going to attach it on up here. Like I did from 9 where I attached on the base, I'm also going to attach it on at the top up here. Okay, so I'm just going to extend on that there. Now, if we think of that point there, which is 9, that's the 9 generator, okay? The distance, okay, along here, 9 to 10, that distance there, the gap from there to there, from that point to that point there, that distance there isn't the distance that 9 is away from 10. It's actually up here, okay? That's the one, because in our plan view, we know that surface there is actually a sloped surface. So really I need to take this distance here. So what I'm actually going to do, okay, using my compass, just get this set up here, is I'm going to take the distance, and small enough I'll actually measure it. So it is 5 millimeters. So what I'm going to do is I'm going to mark up from 9, 5 millimeters. Right there. Okay, and on that point right there, either side of that will be either 10 and 8. Okay, and we can see obviously 8 is here, 10 is here. Okay, that's very, very important to note. Now, what I also need to do is now I need to find the distance from, so I'll just move that there a slight bit. I also need to find the distance from 9 to 7. And 11, which is that distance there, so I'll mark that up as well. I'll do the same then from 9 to 12 and 6, and from 9 up here I'll mark that up. One to 5, from 9 to 1 to 5, and then 2 to 4, and finally, that's just gone out of shot there, but I'll pull it back down, 3. Okay, so I'll just pull that down onto the screen there now. So there we have it. Just there now, perfect. Okay, so along this line here is going to be the 8 and 10. The next one is 7 and 11. Then obviously we have 12 and 6. Okay, after that one was 1 and 5. Then I think it was 2 and 4. And then finally 3. Okay, and 3 is a point on its own, so there I can put in that one. Okay, now at this point what I need to do is from my middle line down here, I need to take the distance, okay, from the center of that line to 10, which is going to be the same as the distance from the center of that line to 8, as it will be the same from the center of the line to 2. Okay, so putting that in, I'll mark it here, and I'll also mark it on this side. And having found them, I can now, because I know they were the same distance, the distance from here to 10 is the same as the distance from here to 8, which is the same as from here to 2, which is the same as here to 4. So I can actually mark them on the ones there we have it. Just looking at that, I said it was 5, just want to be sure. 5. Probably overestimated the first one, but it'll be alright. There we go. So there and there. And now I have 2 more to do. Now I'm going to take the distance from the center to 11, which is that distance there, which will be the same as from here down to 7, same as from here to 1 and here to 5. So I'll mark that in the next set of lines. I'll just do it like this. Could use my t-square and set square now, or I could just keep it going with the compass. So this is very much getting into the higher level aspect side of things, guys, okay? And then finally, I'm going to take the distance, because this is the width, from here to 12, which is going to be 15. And from the middle, mark that out. Here, and here. So marking all of those points, I'm pretty sure, if I just work this way, so going backwards, so yep, this is 8, 7, 6, 5, 4, 3, 2, 1, and then obviously 1 connects to 12, to 11, and to 10. And there we have it. You can see the series of points. So it's literally a case now of sketching that in. So I'll speed up the video once again. Okay, there we have it. That is the question complete there, guys. A little bit in that, just especially the bit there at the end, obviously putting in the kind of elliptical curve that we have there, which is kind of the true shape of this surface here, which we see as a line in this view. Okay, a little bit in that, obviously understanding where to take the various lengths from, obviously coming down here and then taking the widths from the plan. Okay, a little bit in that, but once again, hope you found that helpful, guys. That is the question complete. Okay.